So here's part 2 of hydrocarbon derivatives, focusing on carboxylic acids and esters. So to start off, you have to be able to identify a carboxylic acid, and they have this general formula, R connected to COOH. So this COOH is the functional group. If we did a structural formula, it would look like this, where carbon is double bonded to oxygen and single bonded to an OH group. And then this R just represents either another carbon, could be hydrogen, but it would be the chain. You've seen the COOH group probably quite a lot, because that's one way we identify acids, in particular weak acids. And when it comes to naming, there's only one spot for this carboxyl group to go. So this carbon here will always be carbon 1 of a chain. When you are naming it, so the nomenclature of naming carboxylic acids, you figure out what your longest chain is that has the carboxyl group, and you name your parent alkane. Then you drop your E, add oic acid to that parent chain, and then the rest of our rules will still remain. If you have any side groups, we're going to name them after we're done. So taking a look at the first one, again, we would recognize that this is the functional group that makes it a carboxylic acid. Carbon is double bonded to oxygen, single bonded to an OH group, and this carbon would be carbon 1, and then you have carbon 2, carbon 3. So if we named the parent alkane, it would be propane, but then the rule is drop the E and add oic acid. So this is propanoic acid. Okay. The next one, we're doing the same thing, recognizing this is just a condensed structural formula. So we're noticing that carboxyl group. So carbon 1, carbon 2, carbon 3. I'm going to continue to the left, because if I go up, I would have a not the longest chain possible. So carbon 4, carbon 5. Recognizing on carbon 3, you have a methyl group. So this would be 3-methyl. And then if it's a 5 carbon chain, that would be pentane, but we're dropping the E and writing pentanoic acid. And the last one, showing a line diagram with your side groups. So we have that carboxyl group, carbon 1 would be here, then we have 2, 3, 4, 5, and we have to keep going to get that longest chain. So there are 6 carbons in the main chain. On carbon 2, 4, and 5, you have a methyl group. So this would be 2, 4, 5, trimethyl, and then 6 would be hexane, but we're going to drop the E and put oic, sorry, I needed an O, oic acid. So that's how we name, and now how we draw is similar. Now we're starting with hexanoic acid. So when I mean similar to what we did before. So hexanoic comes from hexane, which means 6. So we'd have 6 carbons in your main chain. And then on carbon 1, whether you start at the left or the right, you just have one of them has to be carbon 1. You have the double bond to an oxygen, single bond to an OH. So what I've done with carbon 1 is added my carboxylic functional group. Now the rest of this chain, because there's no side groups, we need to just add hydrogens. Okay. So I just did the structural formula for this one, and in the next one, because it's a little bit more complicated, I'll do a line diagram because it is quicker. So that's it for the first one. For the second one, we have 3,4-diethyl 2,3,5 trimethyl, but getting to this end part, heptanoic acid. So heptanoic, hepta would mean 7. Oic acid means carboxyl group. So let's do a line diagram here. So I'm starting with my first carbon. So carbon 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. That looks kind of messy. Let's try that one more time. So 1, 2, 3, 4, 5, 6, 7. I don't think that's any better. And on my last carbon is the one I usually make carbon 1 with carboxylic acids. I will do my double bond oxygen, single bond OH group, and this is carbon 1. So then I have carbon 2, carbon 3, carbon 4, carbon 5, 6, and 7. On carbon 3 and 4, I need a ethyl group. So ethyl is 2 carbons. So on carbon 3, I'm adding 1 carbon, 2 carbons. On carbon 4, 1 carbon, 2 carbons. Then on carbon 2, I need a methyl group. On carbon 3, I need a methyl group. And on carbon 5, I need a methyl group. So there's my line diagram for that more complicated compound. Now, I believe this question showed up in the PowerPoint I did yesterday, or the lesson I did yesterday. So just going through this one more time, now that we know carboxylic acids. So carboxylic acid, I'm seeing right now, is on 3. So carbon double bonded to an oxygen with that OH group. That's definitely our carboxylic acid. Aromatic must have the benzene ring. So it only needs 1, but there's 2. That still makes it aromatic. Alcohol, an OH group. So just recognize, number 4. So recognizing that this is an OH group, but it's connected to the carbon, which has the oxygen. So that doesn't make it an alcohol side group because it's a carboxyl group. So it has to be that OH by itself. And then your halogenated hydrocarbon, you must see halogens. And the only place we see halogens is on carbon or compound 2. So we're just repeating compound 2. Our next formula, or general formula, is for esters. Esters somewhat can look like a carboxylic acid because you have that COO. We're still seeing a double bond, but they're a little bit more complicated because instead of just being connected to one chain, you could be connected to 2 chains. So there is this extra note here that they are formed from carboxylic acids. That's where that double bond's coming from, and alcohols. This reaction we get more into when we look at organic reactions, but it's called esterification. So esterification is when that carboxylic acid gets close enough to the alcohol, and then an H and an OH will want to leave as water. So that makes it under the category of a condensation reaction if water is produced. Now whatever's remaining, because now this oxygen needs to bond to something, this chain will need to bond to something. So they come together and bond to each other. So that's where we end up with the 2 products, an ester and water. So you always have a carboxylic acid coming together with an alcohol. So when it comes to naming, I know this is a little bit small here, but you want to identify the part of the ester that has the OH group. That is a part, the ester, that came from the carboxylic acid, and it is going to be the root. Now you drop the OIC from the carboxylic acid and replace it with O8. Then the prefix are essentially similar, but the prefix is coming from the alcohol. So you'll name it as a side group. And then it does add on, there is a space between that alcohol side group and the root name. So if I take a look at this first one, the carbon attached to just the oxygen, that was the alcohol group. So that would be a methyl group. And then the rest, hey, Coco. Sorry, my dog is starting to bark. And then the rest of it, carbon 1, 2, and 3, would be from the propanoic acid. So I'll write propanoate because I drop the OIC and replace it with O8. This next one, same idea. The one that's attached to the oxygen gets written first. So this would be a propyl group because there's 3 of them. And then the carboxylic acid has 4. So that would be butanoic acid. So we'll drop the ic. So butanoate. And add OATE. And our final example here, we have the carbon chain connected to the oxygen that we named first. And it's not always going to be on the right. It could be on the left. We just have to see that it's one single bonded to the oxygen, not the carbon that's double bonded to the oxygen. So that single bond, that's a butyl group. So butyl. And then 2 carbons would be ethanoic acid. So ethanoate. And I hope you can concentrate because mine is starting to go away because of my dog. So looking at the drawing of esters, I like to start with the part that came from the acid. So methane would be C double bond O, single bond O, and then just an H because methane means just 1 carbon. And then heptyl means that this oxygen is going to be connected to 7 carbons. So 1, 2, 3, 4, 5, 6, 7. And when we're done, you can fill in all of your hydrogens. And my dog is just standing here barking at me, which is very nice of her. Okay. Now, my very last one I want to take a look at here has a little bit more going on because we do have some side groups also on the main chain. So here we have ethyl 3,3-dimethyl butanoate. So we can consider this 3,3-dimethyl butanoate all part of that carboxylic acid. So butane would mean 4. 1, 2, 3, 4. That part is with the carboxyl group, so contained to the O. Then this is still carbon 1, 2, 3, 4. On carbon 3, you have 2 methyl groups, so CH3. And then I'll fill the rest of my chain in with hydrogens, since I'm doing a structural diagram. And then attached to my oxygen, I have an ethyl group. So 2 carbons, and I have to fill in my hydrogens. So that's the drawing of 2 esters. And then to finish off here, just now that we can identify an ester, is now identifying functional groups with an old diploma question. So with this one asking just about esters, we definitely are just looking for that C double bond O, single bond to an oxygen, bonded to another chain. So when we're taking a look and going through all of them, we do look at this first one, and lots of students want to pick it, but we're not quite there. So again, we're looking for carbon double bonded to an oxygen, single bonded to an oxygen, and then we have chains. So this R I'm writing in has to be a carbon, because if it was a hydrogen, it's a carboxylic acid. And this R on this side could be either a hydrogen or a carbon. So this first one's not going to work because this carbon here was not an oxygen. If there was an oxygen in there, we almost got it. This part over here represents a carboxyl group, and this part over here just shows an alcohol. So it's not going to be number 1. Looking at number 2, we do have one. It's right in here. So carbon double bonded to the oxygen, single bonded to an oxygen, that's attached to a chain, and then this carbon also has a chain, just happens to be benzene attached to some alcohols. Over here, we don't have one, right? We needed another oxygen before, and then this had to be carbon, so that's not going to work. And number 3, we're taking a look. We do see carbon double bonded to an oxygen, single bonded to a hydrogen, single bonded to another oxygen. So far looking good. And then we have another carbon chain. So it looks like our answer here is 2 and 3. I hope you found this helpful going over carboxylic acids and esters. And if you did, please subscribe and like. And if you have any other suggestions, please leave me a comment of any other video I can do for you. Thanks for watching.